Hello. This is Module 4, Topic 1, Lesson 2. And so this is talking about give the models a chance, probability models. Okay. Our learning goals in this section are going to be to develop a probability model for an experiment and use it to determine probabilities of events. Develop and interpret a uniform probability model, assigning equal probability to all outcomes. Construct and interpret a non-uniform probability model. Our key terms here: probability model, uniform probability model, and non-uniform probability model. You now know about simple probabilities and how to write them. How can you use models to represent probabilities and solve problems? Our warm-up exercises for this section. Determine each ratio. The number of heads to the number of sides of a coin. Okay, well, there's one outcome that would be heads on a side of a coin, and there are two possible outcomes. So my probability would be 1 to 2. And it's a ratio, so probability is kind of like a ratio as well. 2, number of sixes to number of faces on a six-sided cube. Well, there's 1 6 on a typical six-sided number cube, and there are 6 total possible outcomes. Number 3, number of day names ending in day to total number of day names, like Monday, Tuesday, Wednesday. So 7 out of 7 days of the week. And so this has a probability of 100%, and this is a 50-50 equally likely scenario. And this is not. All right, so that is our first page of Lesson 2. All right, so getting started. Pocket probabilities. Molly has 3 pennies, 4 nickels, 3 dimes, and 2 quarters in her pocket. She takes 1 coin out of her pocket and hides it in the palm of her hand. She wants her best friend to guess which coin she is holding. 1. Complete the table. Use a fraction to represent each probability. Okay. So if I look at this, there's 3 pennies and 4 nickels and 3 dimes and 2 quarters. In a perfect world, you'd pause, do the problem, then watch the video. So if I was to add those all up, it would be 3 plus 4 plus 3 plus 2, which is going to be 12 total coins. And so for the pennies, it would be 3 out of 12, which I could leave, or I could simplify it to 1/4. For nickels, it would be 4 out of 12, which I could leave, or I could simplify that to 1/3. For dimes, it would be 3/12, which I could leave or simplify to 1/4. And then for quarters, it would be 2 out of 12, which would be 1/6. Okay. I know that the sum of these probabilities must be 1. And if I think about it, 3/12 plus 4/12 is 7/12, plus 3/12 is 10/12, plus 2/12 is 12/12, which is the same as 1. Okay. When I take a scenario and I take all of the probabilities and add them together, that would be 100% of the chances, and so it should equal 1. 3. What coin would you advise Molly's best friend to guess? Explain your reasoning. Well, golly, if she wants to be right, I think Molly's friend should guess a nickel or a nickel, the nickel. Because it has a higher probability than the other options. Okay, and so that is the getting started. All right, activity 2.1, using probability models. Jorge and Tristan are training to be magicians and are working on a card trick. They have 5 cards of different colors: red, blue, yellow, green, and purple. They are discussing the likelihood of an audience member picking each color, assuming that they can't see the card's color. List the sample space for choosing a card. Again, the sample space is putting all your options in brackets. So red, R for red, B for blue, Y for yellow, as I said so, G for green, and P for purple. Then I have that, and that is my sample space. And so sample space is equal to those being the options. Okay, so there aren't more of any one color. What is the probability of selecting each card? Write the probability for each in the table. Well, you'd have a 1 out of 5 chance of selecting red because there's only one red. That would be the same as 2/10. 1 out of 5 for, 1 out of 5 for blue, which is the same as 2/10 or 20%. 1 out of 5 for yellow, which is the same as 2/10 or 20%. 1 out of 5 for green, which is the same as 2/10 or 20%. And then 1 out of 5 for purple, which is the same as 2/10 or 20%. Okay. Notice it said previously when you listed all the outcomes of an event, you were using a probability model. Okay. And so that's going to tie into what this says right down here. When solving a probability problem, it is helpful to construct a probability model. A probability model is a list of each possible outcome along with its probability. Probability models are often shown in a table, kind of like right here. The probability model for choosing a card is shown. So this right here is a probability model for the card situation. A probability model will list all the outcomes which will be greater than 0, but less than 1. The sum of all the probabilities for the outcomes will always be 1. Why is the sum of the probabilities in a probability model always 1? Well, the sum is always 1 because the model lists all of the possible outcomes. Or 100% of the outcomes. When you add those up, it must be 1 for all the outcomes. main thing to remember here is that the highest probability we can have is 1 or 100%. And if we're making a model for it and we have all the outcomes there, when we add them up, it should add up to 1, as long as all the outcomes are in our table. All right, so we have to choose who's right and who's wrong. Tristan claims the model is correct because the probabilities for all outcomes are equal to each other. All right, so Tristan is saying because all of them were 1/5, then that means that it's good. All right. Jorge says no. The sum of the probabilities is 1, but that does not mean the probabilities of all the outcomes are equal. Okay. Who is correct? Explain your reasoning. Jorge is right. For me, I'm thinking of the pocket probabilities in the getting started. In the getting started section, in the getting started intro, coin problem, the different coins had different probabilities. But it still worked. But the model still worked. Because all the outcomes added up to 1. Okay. And the card trick also added up to 1, even though those were the same. Okay. And so the key thing is that the sum of the probabilities is 1. Okay. Probabilities don't have to be equal. All right. We have 2 vocabulary words here, and so I'm looking at this. A uniform probability model occurs when all the probabilities in a probability model are equally likely to occur. Each color card in the magician's trick had the same probability of being chosen. All of them were 1/5. When all probabilities in a probability model are not equal to each other, it's called a non-uniform probability model. An example would be the weather forecast that states that there is a 30% chance of rain. That means there's a 70% chance of not raining. The sum of these 2 probabilities is 1, but the outcomes do not have the same probabilities. Kind of like the pocket coins also in the intro, where it was the penny. There was 3 out of 12 that were the pennies. There was 4 out of 12 that were nickels. There was 3 out of 12 that were dimes, and then there was 2 out of 12 that were quarters. And so those were not equal, and so that would be a non-uniform probability model. Okay. All right, and so that is the end of lesson 2.1.